Today's lesson involves day 4 on our CT review, collecting like terms. So in this first question, we have 5x squared minus 2x plus 4x squared minus 3x. We can collect the x squared terms and we can collect the x terms. And we can add these two together where they become 9x squared. And we can add these two together to become negative 5x. So that's this question simplified. Over here, 4g plus 6g minus 3 plus 2g. Well, all the g terms, all three of them, can be collected together. And that will leave us with 12g minus 3. Expand and simplify. 2 times x is 2x. Negative 2 times 2 is negative 4. 3 times 2x equals 6x. And 3 times negative 4 is negative 12. Down here becomes 5y minus 5 plus 8y plus 12. Collect our like terms. Leaves us with 13y plus 7. 3 times 2x squared is 6x squared minus 3x minus 5x squared plus 6x. Collect our like terms. Leaves us with x squared plus 3x. Solving equations. Now, it's the first example. Here's a prime situation where we can use cross multiplication to solve. So what we have right here is a 5, and we can read that as 5 over 1. And then we'll simply cross multiply. S times 1 equals S equals 4 times 5. So S equals 20. Once again over here, another example where we can easily cross multiply. If we just imagine a 1 over underneath this 30, 1 times t equals 5 times 30, t equals 150. In this situation, we want to isolate the x term on one side and have all the numbers on the other side. 2x equals 3 minus 7. So what we've done is we've taken this 2x, we've left it here, and we've taken this 7 and brought it over the other side. So 2x equals 3 minus 7 is the same as 2x equals 3 minus 7. Gives us 2x minus 4. If 2 times x equals negative 4, then x equals negative 4 divided by 2, which is negative 2. Over here, again, we want to isolate our variable on one side. So we'll keep the 2x on the left and bring the negative 4 to the other side where it becomes a positive 4. 2x equals 18 plus 4. 2x equals 22. If 2 times x equals 22, then x equals 22 divided by 2, which is 11. Here, we need to expand first. So 3x plus 3 times x plus 2 will leave us 3x plus 6. 4 bracket x minus 5 will give us 4x minus 20. We'll bring all the x terms over to one side and the numbers onto the other side. Will give us 3x minus 4x equals negative 20 minus 6. Negative x equals negative 26. Now to get rid of the negative next to the x, we simply multiply both sides by negative 1, which leaves us with x equals 26. Over here, again, we're going to need to expand first. We'll leave us with 2g minus 8 equals 5g minus 20. Bring all the g terms to one side, our variables on one side, and our numbers to the other, leaves us with negative 3g equals negative 12. Divide both sides by negative 3, leaves us with g equals 4. Evelyn has 1 horse and 10 chickens. The equation C equals 8d plus 100 represents the total cost to feed the animals for a certain number of days, d. If Evelyn has $2,700, could she feed them for the entire year? So we'll just restate our equation. Cost equals 8 times days plus 100. What do we know? Well, we know, or we're told, that the cost that we have is $2,700. But there are 365 days in a year. So we want to know whether our cost of $2,700 is greater or less than 8 times 365 plus 100. 8 times 365 plus 100 equals 2,920. So this is how much it's going to cost to feed the animals for a whole year. If she only has $2,700 and the cost is $2,920, then we can say that she would not have enough to feed the animals for an entire year. Use the formula distance equals speed times time to determine Dakota's speed in kilometers per hour if he runs 10 kilometers in 0.95 hours. So we'll restate our equation right here. D equals S times T. What do we know? Well, we know that the distance is 10 kilometers, and we know the time is 0.95. We don't know what the speed is. So by plugging these values of what we know, we can isolate for S and figure out what the speed is. 0.95 S equals 10. S by itself will equal 10 divided by 0.95. The speed will equal 10.53 kilometers per hour. Here we're asked to solve by graphing. So we're given 2 equations and we want a solution to it. Now the solution simply means the intersection. Where do these 2 lines intersect, or do they? Well, what we need to do with this particular one is we need to take it and put it into slope-intercept form. This is already in slope-intercept form, so we don't need to do anything to this before we graph it. This one we need to modify a little bit, isolate the y by itself until it's in slope-intercept form, which it is here. Here, the slope is 1 and the y-intercept is 3. Here, the slope is negative 3 and the y-intercept is negative 1. If we take our y-intercept for this one, 3, and we graph it, we get a line that looks something like this. Whereas if we graph this one, we get a line that looks like this. Okay. Our solution is the point of intersection, -1, 2. Here we're given 2 equations, y equals -2x minus 5 and y equals 4x plus 1. Our slope for this equation is -2, and our y-intercept is -5. Our slope for this equation is 4, and our y-intercept is 1. When we graph these, we see that they intersect at the point -1, -3. This is a mistake. This should be -3. Solve by substitution. When we solve by substitution, we first need to make sure that both our equations are in slope-intercept form. Both of the right-hand sides are equal to y. So these are both in slope-intercept form. So if these are both equal to y, then they are equal to one another. So we can say that the right-hand side here is equal to this. We can say that 2x minus 21 equals -2x plus 3. Now we simply isolate our variable. We get our variable on the left-hand side and our numbers on the right, and solve for that variable. And we're left with a value of 6 for that variable. Once we have one variable, in this case x, then we can substitute that variable back into either one of these equations and find out what the other variable is. So we'll take 6, we'll substitute it into this equation right here, and that will tell us what y is. And it turns out that y is -9. Therefore, our point of intersection, or our solution, is 6, -9. Once again, we're asked to solve by substitution. In this case, both our equations are already in slope-intercept form. So we can say that this is equal to this. Once again, we gather all our variable terms on one side and our numbers on the other, and we solve that variable. So we're solving for x here, and we end up with a value of -8 for x. Once we have a value for one of our variables, we can take that value and plug it back into one of the equations. In this case, we'll plug it back into this equation and solve for the other variable. And we end up with a value of -15 for y. So our point of intersection is -8, -15. In question 3, we'll solve by elimination. What we need to do is we need to try and get rid of either the x's or the y's, either by adding or subtracting these together. Now, as it stands now, we don't have the same x values or the same y values. So we have to add another step before we can solve by elimination. If we took this first value and multiplied it by 5, we'd multiply both sides by 5, we would get 5x plus 15y equals 25. Now we can use that second one, the second equation. We have similar x terms, so by subtracting, we can get rid of our x terms. 5x minus 5x is 0x. 15y minus 2y equals 13y. 25 minus 12 equals 13. We can solve for y, and we get a value of 1. Once we have a value for one of our variables, we can take that value and plug it back into one of the equations. We'll plug it back into this one. So we'll take that 1 that we came up with, plug it into the equation, and solve for x, and we get a value of 2. So our point of intersection or solution is 2, 1. In this elimination question, we have a negative y and a positive y. So we can get rid of the y's simply by adding them together. So if we add x plus 2x, we get 3x. Negative y plus y eliminates the y's, and 3 plus 3 gives us 6, resulting in a value of 2 for the variable x. Once we have a variable for x, we can substitute it back into one of the equations. So we'll do that, and then that will give us a value for y. So we get a value of negative 1. So our solution, or point of intersection, is 2, negative 1. Number 4, checking your solution. Check to see if the point negative 3, 2 is a solution to the following linear system. So we have two equations here, 2x minus 3y equals negative 12, and 6x plus 5y equals negative 8. So the question asks, do these two lines intersect at the point negative 3, 2? Well, by plugging in these values into these equations and checking to see if the left side equals the right side, we can determine if it's a solution or not. So we'll take these points negative 3, 2, plug it into the first equation. 2 times negative 3 minus 3 times 2 simplifies to negative 12. Left side equals right side. So far, so good. Taking those two values, x, y values, and plugging them into this equation, 6 times negative 3 plus 5 times 2 ends up being negative 8. Left side equals right side. So we can say that this is a solution or a point of intersection. Check to see if the point negative 1, 10 is a solution to the following linear system. So here we're given two equations, and we need to check to see if the left side equals the right side in both those cases. So we'll take the values negative 1 and 10, we'll plug it in, and we can see that for the first equation, the left side does indeed equal the right side. So we're good so far. We'll try it with this equation, plugging in the values negative 1 and 10, and see if the left side equals the right side, which it does. So we can safely say that negative 1, 10 is a solution. You can see this here on the graph.